So let's learn about variables and data types. So variables in Java can get rather complex, but they needn't be. They're actually, they may look complex, but they're not complicated. So, but there's a lot of modifiers that you can see that we can throw onto a variable, like public, static, final, double. Variables, whether they're public versus private, whether they're static variables or instance variables, terms that we're going to cover much more later, right? They, whether they're final, meaning they can't change, or whether they're changeable. And of course, the type of the data, whether this is a floating point number, an integer, or something way more complicated than that. So there's a lot of different, so there's three primary types of variables. You can have your static variables, your instance variables, but we're going to talk about those later. This video focuses on the local variables, which are variables which exist within a method. So Java is a strongly typed language, which means when we create a variable, we just create it once for the first, and its type will remain the same. So to declare a variable, we just simply write the type of the variable you want and the variable name. I should probably explain first, though, what these little tick marks are. These are comments. 2 slashes are a comment in Java, and what that means is that the compiler, the Java compiler, Javac, will ignore everything after them. It will just completely ignore it. It's not going to see anything on this line afterwards, right? Without these be causing an error because Java would be going crazy trying to figure out what the heck was going on there. But comments are ignored by the compiler, and they're nice, useful things for us to be able to read. So they're like little notes. So Java is a strongly typed language. So to declare a variable, to create a variable and say it's ready to be used, what we do is that we say the variable type, so maybe int for an integer, and then the name. We'll call this one x, just to represent a number. And then we put a semicolon. And this creates a variable which has not been assigned a value yet. It is of type integer, which means that it's a 32-bit number. And we'll get into that and what that means in more detail. But all you have to know is that we've basically created an empty space for it. We can't really use it for anything yet because we haven't given it a value. To assign a value, we use the assignment statement, which looks a heck of a lot like the equal sign because it is the equal sign. So it looks like this. We use the name of the variable, and then we put on the right side of the assignment statement the value. But it's important that we think of this, x is equal to 5, as more like an arrow. Because what happens here is that basically we're not saying x and 5 are the same thing. We're saying the value on the right gets copied into the left. The value on the right gets copied into the variable on the left. You're going to hear me repeat this a whole lot in this class. So here, x will have the value of 5. I can actually prove it to you at this point by printing out x. 5. And there we go. If, for instance, I wanted to print out x plus 1, no worries. It will print out 6. So it works exactly kind of the way you would like it to. We can typically combine these two things into a single statement. And that's typically the way it is. You typically declare it and initialize it. So you declare it and give it its initial value all in one go. Int y is equal to 7. And here we can do a print line statement again, and we'll print out y. And again, it's important that to remember that we only write this type statement when we are initially creating a variable. Any other time we don't need to do it, right? If I try to do int x over here, it's going to give me an error, right? Because when we put the type of a value in like this, Java is assuming we want to create a new variable. And it's saying we can't create a new variable called x. X already exists. Unlike other programming languages, you have to declare a variable in order to use it. I can't just simply say z is equal to 10. Java is strongly typed, meaning that we have to declare it, and we can't change what kind of variable it is afterwards. So for instance, I can't put I can't, just use z out of the blue. I'd have to create it. So int z is equal to 54. And furthermore, I can't change the type of z. I can't say now it's a string. Can't do that. Right? It says incompatible types. We want to put a string. You want to put a string in here? Well, you can't because it's an integer. This is just to prevent you from really hurting yourself by forgetting what variables can be. Furthermore, about assignment statements, what goes on the right is a expression. So it can be any expression. So it could be 7. So that's a simple expression, just having a single integer there. Or it can be something like this. 7 times x plus 12, right? This is going to evaluate this entire expression using the standard order of operation rules that you've learned all the way back when you were initially learning algebra. And it will run it, and now we get 47. So, but what kind of different types are there? Because right now I'm just talking about integers, and I mentioned something about 32 bits, so maybe I should talk about that a bit more. Types have two broad categories in Java. You have primitives, and you have objects. And right now we're just going to focus on the primitives. There's one special object, which is strings, and we'll get into that in more detail later. But primitives are fairly straightforward. They just simply store the data you put in them, and they're used as building blocks to create more complicated data types. They are the most fundamental values, and they're fairly straightforward. So the first primitive we've already learned, which is a int. So int num is equal to 213. Now, this creates a integer primitive, right? And what this means by integer is that, first off, only real numbers need apply, meaning that basically not real numbers, only whole numbers need apply, meaning that we can't use a floating point number. These are whole numbers. So 1, 2, 3, 4, you're counting numbers, right? But also 0 and -1, -2, -3. So these are a bunch of, so your positive whole numbers, your negative whole numbers, and your 0. Now, when I say these are 32-bit, I mean they have a certain range, and that range is defined by the number of bits we can store for that number. So when you say int num, we are allocating 4 bytes, or 32 bits. A byte is 8 bits, so 4 times 8, so 32 bits, to store this data. And it has a value which is the range of those values are from about -2 billion to +2 billion. More precisely, -2 to the 31st power to +2 to the 31st power -1. With one of those bits being set aside for being for the negative and positive sign. So, right, I can go up to basically, so here I'm doing 400,000, 400 million, but as soon as I try to do 4 billion, it gives me an error. Integer number is too large. We'll talk about how we get around that later, but just know that that basically we have a certain limit for integers. You also have your doubles, because they're double the length of another type called a float. But we primarily use doubles, which are 64-bit numbers. And they're 64-bit floating point numbers. And they follow this very interesting IEEE specified scientific notation. But we can store basically any kind of floating point, any real number in there, positive or negative, and it can store really, really big numbers and really, 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 really small numbers. So doubles we use for our floating point numbers. Integers we use for our so ints we use for whole numbers. What other primitives are there? There are your characters, so char Cs. Now those differ from strings in that they use single quotation marks and they only use a single character. Only a single character, as opposed to a string, which can be a bunch of characters, right? This gives me an error. So for characters, you only use a single string. Now what's interesting to note is that characters are really just integers in disguise. So let me go ahead and just print out some of our stuff, right? We see num. That works out fine. Print out d. That works fine. Print out q. So now we print out c, and that will work out fine. But if I do c plus 1, first off, that's completely valid, which is interesting. And it will give me 114 if I add 1 to that. Which really doesn't make sense, but the reason it's doing that is that it's saying you want the is that the ASCII value, which we'll learn about in a bit more detail when we get into encryption. The ASCII value for this for Q is 113, and so it's saying so adding 1 to it turns it into an integer, and says what is the ASCII value after 113? It's 114, and so if we want the next number, we can do that. Also interesting to note is that that characters in the most recent version of Java are use UTF-8. So that means we can use non-English characters like so. Let's go ahead and type ko, right? And no problem there. And then if we want to know if we want to get the next character, and that's at, by the way, so if we add +0, that should convert it into the same number it is, right? And that has a Unicode value of 12,371. If we want the letter after that, you can just simply say C plus that character +1. And what I'm doing over here, this thing in parentheses over here, is something called casting, which says, I know that adding 1 to this turned it into an integer automatically, but if I put this over here in parentheses, I want to cast it as a character. I want to treat it as a character. So that's one way to convert these numbers. And notice that it looks the same, except it's got these little marks over here, which basically turn this from a ko to a go, from a unvoiced syllable to a voiced syllable. What else can we do with these? Well, it's important to note that basically we can store whole numbers in a double, no problem. And what happens then is that just like how we were adding a number over here, Java automatically converts that this integer into a double in order to store it into a double. The reverse process doesn't actually work though. So if we did num equal to 3.1415, right, it will say, hey, it's taking a double and you're trying to store it in an int. A double is much too large for an int. You can't store it in there. And so it gets really upset and gives us an error. So you can't do that. One more type to note. So we've got our ints, we've got our doubles, we've got our characters. Okay. And the rule that you want to follow basically when it comes to numbers is that basically the biggest type of number wins. So you can go from an int to a double, and so but going from a double to an int, not so much, right? Same over here. If we ever to do sout 3 divided by 4. Well, actually, this gets into another interesting thing. 3 divided by 4. So we've got 3 divided by 4. You might get an interesting result there. You get 0. Now, why do we get 0? Because when we have an integer divide by integer, right? 4 doesn't go fully into 3, so we end up with 0 remainder 3, or 0.75. But for integers, it can't display 0.75. So it gives us 0, the quotient, right? 0 remainder 3 over here. However, if one of these numbers is a double, it will do, we've got a double on the left, a double on the right. Integer on the left, a double on the right. Integers and doubles can't play together, so we have to convert an integer into a double in order to do that. We're going to convert that integer into a double, and then we're going to run it. And that gives us 0.75. The final type, as I was saying before I got completely distracted by that, is the Boolean. Now, Booleans are named after George Boole, who worked on Boolean algebra, and they just simply store true or false. So true or false with lower cases. And we'll be using those in Boolean statements for on our if statements. Every single primitive does have what's called a wrapper class. So ints have the integer class. So integer dot max value. So this has a bunch of useful things like integer dot max value, which, is the maximum value you can store an integer. So that's the biggest value, positive value an integer can have. It's also got other useful features, such as being able to parse strings for a value. So for instance, if I did num is equal to 213 in a string, this happens a lot when you're reading text. You can't convert an integer into a string. It just doesn't work. But the integer class has a useful function called parseInt, which takes in a string and will figure out what integer is inside of it. So, and there's a corresponding class. So, capital D double for doubles, capital C character for characters, and capital B Boolean for Boolean, which has a bunch of useful classes. So that's all I have to say about primitives at the moment. If you want to learn more about characters in UTF-8, Tim Scott from Computerphile has a great video. I recommend watching it. But this is about the basics for variables in Java. There are some other primitives like shorts and longs, and they're fairly easy to explain. A short is just simply 16-bit integer. It's a short integer, and a long is a long integer, 64-bit integer for use, and they're useful for storing smaller and longer numbers respectively. But we'll primarily use ints, doubles, characters, and booleans.